Alright, we're starting topic 6.1. It's a section on inscribed angles. The definition of an inscribed angle is an angle with its vertex on the circle and whose sides contain chords of the circle. So if you look at the first example, we're going to name the inscribed angles. I'm going to number them. Let's number the one up here in this angle O is angle 1. We'll name this one 3 and this one 2. So those are really the inscribed angles because they each contain a chord and a vertex on the angle. So let's name them. Angle 1 is DOG. That's the first inscribed angle. The second one is OGD. And the third angle is ODG. And if we name the intercepted arc is when you have, look at DOG. Excuse me. DOG intercepts the arc DG, because that's where the chords end. These chords end at these points, and that's going to be your arc that intercepts that angle. If you look at angle 2, the chord OG and DG intercept this arc. So this would be DO. And then the last one, angle 3, is the arc OG. Okay, look at the first theorem on this page. It says if an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. So let's do one where we know the arc and we have to figure out the angle. On this one they tell us that the arc BC is 100 degrees. Now if you notice, this is a diameter, so the entire semicircle here would be 180. So this piece of that arc would be 80 degrees. So half of that arc, that intercepted arc, gives us the angle. So half of AB is 40. So your degree of your angle would be 40. Just remember, anytime you have a vertex on the circle, the intercepted arc, if you take half of that, it'll give you your angle. Look at the next theorem. If two inscribed angles of a circle are congruent circles, intercept congruent arcs, or the same arc, then the angles are congruent. So that just means if you have a circle where there's, like on this one up here, if I were to draw another angle somewhere but still use 80 degree, the endpoints AB, if I drew it in here somewhere, we would still get a 40 degree angle. That's what that means. Alright, next page. Example 3. It says in circle Q that ST is 68 degrees. I think I'll label that. That means the arc out here is 68. And they want us to find angle 1 and 2. If you notice, angle 2 and angle 1 both hit this intercepted arc, so that means they're the same angle. They're both going to be 34 degrees because they're half of the intercepted arc. If an inscribed angle of a circle intercepts a semicircle, then it's a right angle. So see how this is a semicircle and these chords hit at F and G? That means X is a 90 degree angle, because if the arc out here is 180, half of that is 90, so that's going to make it a right triangle, or that triangle will be a right triangle. Alright, let's try example 5. In circle A, angle 1, let's find that one. Angle 1 is right here. It's 6x plus 11. Angle 2 is 9x plus 19. Angle 3 and 4, they give you expressions. Now they tell you that PQ and RS are congruent. Let's mark those. Where is that? PQ is this arc right here, and it's can be congruent to RS. So that means these are congruent angles. 3 and 4 have to be the same angle. And also it means, I'm going to go ahead and draw a little right angle box right here because it's a semicircle that it intercepts. That's a right angle right there. So we can now figure out, let's see, let's do angles 1 and 2 first. 1 and 2, 6x plus 11 and 9x plus 19 have to add up to make 90 degrees. Because this angle T is 90, 90 and 90 is 180. In a triangle they all have to add up to 180. So we know that's going to equal 90. Let's see. That would be 15x. What is that? 30 equals 90. So 15x would equal, subtract 30, 60. If you divide 15, 60 divided by 15 is 4. If you substitute a 4 back in for this one, that would be 6 times 4 plus 11. That's 35 degrees. And 9 times 4 plus 19. Try that. It is 55 degrees. Alright, that means that, let's see, these arcs, trying to figure out how we're going to do T. Let me think. Well, we know 3 and 4 are equal, so let's solve that equation, because we know that because they intercept the arcs that are the same, the arc measures that are the same, then the angles are the same. So let's try that. 3y minus 25 has to equal 4y minus 25 has to equal 3y minus 9. Let's do the y's first. That would give you y minus 25 would equal a negative 9. If you add 25 to both sides, what is that? 16. So y is 16. Let's plug that back in. 4 times 16 minus 25 is 39. And remember, they're equal, so let's just make sure it works. 3 times 16 minus 9. Yep, that one's 39 also. So both of those angles are 39. These up here. These are 55 and 35. Alright, the next theorem is if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Since this is on the next page, I think I'm going to draw you an example what that means. A quadrilateral means four-sided polygon. So let me move this up. So a four-sided polygon, inscribing it just means that if I were to draw 4 vertex points and then sketch a polygon inside it, I think I'll number the little angles. 1 and 2 would add up to, supplementary means 180. So if we had the measurement of angle 1 and we add it to the measurement of angle 2, that would equal 180. That's what supplementary means. Opposite means across from each other. So those are opposites. If I put a 3 here and a 4 here, these are opposites. They would also add up to 180. That's what this theorem means. Now let's turn the page and let's work an example with that. Alright, example number 6. See how they've got an inscribed quadrilateral? Let's label on the picture the measurement of the angles that they're giving us. 95 is the degree of angle T. Angle S is 100. Okay, now this means an arc. So TR, that means from this all the way over, T to R, let me think, it's 160. I don't know if that means this way or this way. I guess it's going to have to mean this way because TR is 160 degrees. Half of 160 is 80, so that makes this one 80. It has to be R. You know what? I think I'd rather that say TSR. Why don't we cross that out and change that? TSR, the arc TSR is 160, so that inscribed angle would be 80 because it's half of the intercepted arc. QS is 170. Let's call that one QTS. I think it's a little confusing. It does mean the major arc, but let's change that one too. So QTS, that means from here all the way across is 170. Half of 170 is 85. So the one opposite that is 85. Another way to do this when you actually really didn't even need these arcs because of the theorem we just learned, the opposite angles have to add up to 180. So your angle Q is 80 degrees and your angle R is 85 degrees. Alright, the next one, let's try this one. They want find the value of the inscribed angle. Now this one has a central angle and an inscribed angle. They want the measurement of the one that's inscribed, so they want XZY. Now if you look at this one, the central angle is given to us by that right angle box. That means the arc out here is the same as the central angle. So the angle, the measurement is always half, so that makes this one 45 degrees. Remember the inscribed angle is always half the intercepted arc. Oops. Sorry. 45. Let me blot that out. Messed up. Alright, the next one, let's try this one. They want you to find the value of x. And this one you're going to use what you've learned about intercepted angles. We know that this angle is half of 120, so we know the expression for that angle, 3x minus 3, has to equal half of 120. So we'll go ahead and set it equal to 60. If you subtract 3 from, if you add 3, you get 3x equals 63. If you divide out the 3, your x would equal 21. So that means 21 is your x. Okay, one last example in this section. Here we have a hexagon that's inscribed. Now, because it's all sides, okay, it does tell us they're all congruent. They could have used the word regular. See how it says all sides of the hexagon are the same? So if all of them are the same, we could figure out the degree of all the angles, the central angles. I think I'll draw one just to explain this. This right here, from your center out, we would have 6 of those, and they would all be congruent. So that really means all these arcs out here are the same. Well, if it's a hexagon, this little angle, the central angle, is 60, and so is this one. You have equilateral triangles inside a regular hexagon. So CD would be a 60-degree arc. BFE, the angle BFE, if I were to draw that one in, is right here. Okay, they didn't draw BE, but it looks like that would go through the center. So that would be a 90-degree. That would be a right angle because that's intercept. Another way to look at this is you have 3 60-degree angles, and so 60, 60, and 60. That right there is 180. So half of 180, your inscribed angle here would be 90. The last one, BCD. Where is BCD? Okay, BCD is talking about, let me grab a, well, I'll just mark it. This angle right here they're talking about. So on this one, if you look at it, you have 60, 60, 60, and 60, that's going to be 240. Half of 240 is 120. So that's really just a bunch of inscribed, these right here are just inscribed angles. Alright, that's it.